All right, so welcome to day 2. We are going to start looking at chocolate tempering. Uh, the principles and methods behind crystallization. Precrystallization is the word we're using now for tempering instead of the word tempering, although people still use it interchangeably. But the idea behind precrystallization is that we're actually causing the cocoa butter in chocolate to crystallize. And by doing that in a controlled way, we can make chocolate that will harden correctly, and it'll taste right, and it'll look right. It'll be exactly what we want it to be. But why do we have to temper it? Well, all chocolate that we get when we buy it is already tempered when we buy it. They tempered it in the factory. But once you melt it and try to make something else out of it besides, let's say, chocolate chips, you can't just use it the way it is anymore. You have to retemper that chocolate. It won't harden correctly without it, and it won't taste right. It won't have the right texture. So tempering ensures some really good things to happen. It ensures good shine. Chocolate usually is very dull when it's not tempered. It ensures good snap. So a good snap means that when you bite into it or when you bend it, it will not bend. It'll break and break with a nice clean snap. And then it has a good mouthfeel and texture, which means that it melts at the right temperature and that it has a nice smooth texture. We can use a few different methods for tempering chocolate. The most, probably the oldest, is the tabling method, and it's done right on a flat surface. The seed method is what we'll use primarily, where we add seed, basically little pieces of tempered chocolate, into a bowl of melted chocolate, and the tempered chocolate causes the melted chocolate to become pre-crystallized. And there's another method that's similar to the seed method called the block method, where we put a large chunk of chocolate into a bowl of warm melted chocolate. So here's some illustrations for you. The tabling method is really done on a surface. So marble is probably the preferred surface to use because it's cool, but you could use a metal table. You could even use the back of a sheet pan. The seed method, on the other hand, is where we take a bowl of melted chocolate and we put in ground up or chopped up small pieces of tempered chocolate. And then there's the block method. The block method does a fine job. It just takes a little longer and takes a little more patience. All of these methods can do the same thing because effectively what they're doing is they are giving the chocolate what it needs in order to become pre-crystallized. Now, those things that it needs are time. So you need time to melt the chocolate, you need time to agitate the chocolate, and you need time to cool the chocolate. You'll also need temperature. Now, the temperature has to be carefully controlled because chocolate melts at a certain temperature, and the different types of crystalline structures in the cocoa butter, they harden at certain temperatures. And if we can control that, as I say, we'll get a good result. And then it needs agitation. In order to encourage that crystallization to happen, agitation is necessary. Agitation helps the crystals, the little tiny precursors, the precrystals, to find each other and form larger crystals and to form a network. That is what gives chocolate its snap, is having that nice crystalline form that is nice and even. So while this sounds all rather technical, let's take a look at what we call the crystallization curve. So we first start by melting our chocolate to 110 degrees Fahrenheit. Around 110. Some chocolates call for 113, but it's right around 110. And what that does is you're getting it up high enough so that all of the cocoa butter melts, including out of all the different types of cocoa butter crystals, the ones that melt at the highest temperature need to get up over 100 degrees, I'd say, to really turn to fully turn to liquid. But once you get it fully melted, the chocolate is formless. It has no crystalline structure at all. So then the next step in the crystallization curve, the next step we do when we pre-crystallize chocolate, is we drop that temperature. And we drop it drastically down to 84 degrees. That's about, as I say, about a 25 degree drop really quickly. We do that through putting it on a cool surface like is in tabling, or we add seed to it. Seed will cool it down, but also the seed will melt and the crystallization that's already in the seed will help the rest of the chocolate start a chain reaction, and we'll get really good crystallization. But we will notice when we drop that temperature down, it will start to get very thick. The chocolate will start thickening. That's a really good sign. So then, once we are at that stage, we will usually test the chocolate to see if it's behaving correctly, if it's really in temper. And if it is, we'll warm the chocolate again up to 88 degrees. Now, 88 degrees is considered to be the working temperature of chocolate, for dark chocolate, that is. It is fluid enough to do a good job and to do what we need it to do, but also it's still under the crystallization temperature that we don't want to go over. If we were to go over, when we rewarm it, if we went over 91 degrees, it would start to melt again, and what would happen is we'd have to start over. The whole time while we're doing this, we're agitating. So we're agitating on the way up, we're agitating on the way down, which means stirring with a rubber spatula, and pretty vigorously at that, really trying to make sure the chocolate is changing evenly. So the temperature is rising evenly, it's dropping evenly. You don't have warm spots and cold spots in your bowl. That agitation ensures that. And of course, when we're rewarming, we're also agitating, trying to make sure everything stays even. The more we can control it, the better results we'll get. So it always behooves us to do the best job we can. So step one, we'll put the chocolate over warm water, not boiling water, but nice warm steamy water, agitating constantly until it reaches 110 degrees. When we reach that temperature, we know that it's fully melted. In time, with experience, you'll be able to tell when it's about 110. But you can use a thermometer for this to make sure that your chocolate's at the right temperature. The next step would be to, if we're tabling, we'd be pouring about 2/3 of our chocolate out onto the marble slab or sanitized surface, and we'd leave the remaining third in the bowl. That remaining third is still quite warm. It's still fully melted, but the chocolate that's going on the marble is now going to start cooling rapidly, and that's going to start instigating the crystallization that we're looking for. Then we're going to agitate that chocolate. And by agitating, I mean we're going to be scraping it up with a bench scraper. You can see the bench scraper. You're going to need to have a bench scraper and an offset spatula to do this method. And you scrape it up into a central pool, and then you spread it out again, and you scrape it up again and spread it out again until it begins to thicken and cool. And what that's telling you when it's thickening and cooling is that crystallization is taking place. And that's a good sign. That's exactly what we want to see. Because after we've done this, and after we've agitated, we're going to return the rest of that chocolate that's on the table to the bowl, where the chocolate is still untempered. Now that that chocolate is thickened and the pre-crystallization has taken place, when it goes into the bowl with the rest of the chocolate, it will start to teach that other chocolate what to do. So basically, now we have started that process, a chain reaction to start happening in the tabled chocolate, put it in the bowl, and that chain reaction will start happening in the bowl. And your whole bowl of chocolate will become pre-crystallized. And when it's pre-crystallized, it's basically ready to use. We can be sure that the chocolate will do what we want it to do. It'll have good shine, it'll have good snap, it'll have good mouthfeel. But there's another aspect of tempered chocolate that makes tempering chocolate very important. And that is that when chocolate is really tempered properly, it shrinks a little bit when it hardens. And because of that, you can use it in things like molds, and they will pop right out. If chocolate is not tempered, on the other hand, it won't shrink and it won't pop out of molds. So to make sure that we're in temper, we're going to test it. We're going to test that chocolate. I show an illustration here with a spoon. The picture on the left with the spoon is still very shiny, very, very glossy. Tells me when I look at it that the chocolate is still too warm. It has not pre-crystallized yet. The chocolate on the handle of the spoon, on the other hand, is pre-crystallized, and you can see the difference. When chocolate is not pre-crystallized, it doesn't harden on its own. Instead, it stays glossy, it stays melted. When it's properly pre-crystallized, it will harden naturally at room temperature and form not a glossy shine, but a gentle shine. And you can see that on this offset spatula. We put a little tempered chocolate on here, And after about 3 to 5 minutes, it starts to harden on its own. No need for refrigeration. It will harden properly because it's pre-crystallized. Sometimes I use a little slip of paper. I'll use a little slip of parchment paper. But really, any tool will do the job because it just needs to be something that's benign. It's not cold, it's not warm, it's just room temperature, and that will give you a better test. I like to use plastic spoons. They work really well because they don't hold temperature. So they will let the chocolate naturally harden if it's properly tempered, and it gives you an accurate test. So once we've gotten through the test and we're assured that it is in fact tempered, and we see that gentle sheen start to take over, it starts to dull slightly, but still has a nice sheen. That means that it's ready to use, and it's ready to make things out of. So if properly tempered and you get a good test, raise the temperature of the chocolate to 88 degrees or to the working temperature. So we return it to the steamy water, put the bowl on top, stir it constantly, and what that's going to do is the temperature will start to rise just ever so slightly. Now we've brought it down to about 84, so bringing it up 4 degrees won't take very long. We'll put it on the water, it'll just start to warm up a little bit, and you'll notice that the chocolate, as you're stirring it, will start to go from being fairly thick to being a little bit more fluid. That's a really good sign. Then pull it off the fire and clean off the bottom of your bowl and get ready to make things with it. Just a little mention about the bowl on hot water. Water is the enemy of chocolate. If we even get one droplet of water in our melted chocolate, it will cause the chocolate to seize and turn into something like clay. After that, the chocolate isn't very good for much of anything except making chocolate ganache. So we don't want to get water in the chocolate. So when you pull a bowl off of a pot like this, you need to take a dry rag and wipe off the bottom of your bowl to make sure no stray water finds its way onto your bench, and thereby it doesn't find its way into your chocolate. So we're going to be going to the lab, and when we get into the lab, when you arrive, I'm going to do a quick demo of this process, but at the same time, you're going to need certain tools at your station. You're going to need a heat source. So you're going to need one of our induction burners. You're going to need a saucepan. Just check back by the dish station. You'll find saucepans on the shelf. And you need to put about 1 inch of water in there. Bring up that water to a boil, and then turn the fire down so it's just barely simmering. You'll need a stainless steel bowl to melt your chocolate. You're going to need a dry towel for drying off the bottom of your bowls, and you're going to need a damp towel for general cleanup. A rubber spatula for stirring. You're going to need a few plastic spoons, so grab a few for testing your chocolate. Make sure your table is clean, it's free of clutter, it's sanitized, because we're going to be using that surface for ready-to-eat chocolate. So we can't, we got to make sure that it doesn't have any sort of contaminants on it. You're going to need a bench scraper and a large offset spatula if you're going to be tabling. But initially, I'm going to demonstrate for you how to do the seed method, and then we can work our way up to tabling. A cutting board and a chef's knife if you do need to chop the chocolate, but generally our chocolate's in small pieces anyway, so you may just want to put that aside. And of course, you need chocolate. Finely chopped is a good idea because it melts more evenly, it melts quicker, and it's easier to work with. So we'll see you in the lab. I want you to make sure you're in uniform. Bring your mask, and we're going to hit the ground running when we get there and start diving right into tempering some chocolate. Once we have our chocolate tempered, we're going to be making things out of it throughout the day. So be ready to make some good chocolate truffles. We're going to make some chocolate decorations and things like that. All right, see you then.